So what we're going to look at now is we're going to approach this from kind of like an abstract perspective. So this is like the concept that you need before you can start applying it to those situations. So keep that in the back of your mind that there is some very strong applications of this. But I want to show you first, right, these two equations here. And these are how we're going to represent these. Okay? So just coming back, guys. Here's two equations. And hopefully, if you haven't been following so far, but the linear functions are going to be really important for this. So if you're not too sure on that, you might want to go back on that one. Saxon, just coming back. If you're not too confident in those skills, you might want to go back and have a look at those. But you're going to need a pretty good knowledge of these linear functions in order to approach these, right? So we've got two equations here. Y equals to x plus 4, y equals to minus x plus 4. Just before we get into it, how do I know which one's which? Well, there's one very distinct feature about them. Well, there's actually two, but the one that I look for is the gradient, right? What's the gradient of this line? The gradient of this line is positive. And Emily, which one's the positive gradient on my graph here? Yeah, that way. That way. It's going up from left to right, so y equals to x minus 4. And the other thing you can tell is this guy here, this is the y-intercept, and that's where that y-intercept is. So if you're not too sure about that, that's another way you can tell. And here's the other one, y equals to minus x plus 4. We can see that it actually checks out, right? So we've got a y-intercept of positive 4. That's where it crosses the y-axis there. Yeah. And that's got a negative gradient there. It's got a negative gradient, okay? But that's not the question. I'm just giving you an overview of what these are. The question is, identify the point of intersection. What's the point of intersection here? Where they cross, Jack. Where do you reckon they cross?
On the 4.
On the 4, that's right. And when they say the point of intersection, be careful. Make sure you actually answer the question carefully. 4 is correct. That's the x value, right? But what's the y value? 4, 0. Good stuff, George. Yeah. So 4, 0 is the point of intersection. Here's another way to think about it. If they say identify the solutions to this, essentially what this is saying that 4, 0 is the solution to these pairs of equations. So in year 10, if you're in 5.3, you might have looked at something called a simultaneous equation. You don't need to know how to do that algebraically, but what they do ask is that you know how to do that visually. And so visually, the solution to a simultaneous equation, if they ask for the solutions, there's actually going to be two answers there. Because if you look at these equations, the equations that you're used to seeing, it's something like this. X plus 5 is equal to 2, right? And then you can solve it that way. You can say x is equal to minus 3 or something like that. But these equations here, what's different about these equations? There's two what? What are they called? There's two letters, there's two variables, and there's also two equations. So actually, when you have a simultaneous equation, we call them simultaneous because there's two of them, you actually need two answers. You need an answer for x and an answer for y. What are our answers for x and y? I heard it? Yeah? 4 and... Well, what did we just find earlier? 4 and 0, right. And so here's the thing, right? This point of intersection is actually also what we call the solution to the simultaneous equation. What coordinate is that first one? Well, it's an x coordinate. So x is equal to 4 is the solution for this. And the other solution was y is equal to 0. And let me just show you that algebraically, right? If you put in x equals to 4 here, what happens? We get 4 minus 4, which is 0. That's why but which is why. And then the same thing over here, when you put x is equal to 4, negative 4 plus 4 is also. Right, and so you can see, this is what we call a simultaneous equation. Because actually, if you wanted to solve these without using those methods, it's hard to just come up with those numbers. You can't just apply this kind of method of balancing them out because you've got these two letters here, okay? So that's how we can find the solution to a simultaneous equation. You only need to worry about that graphically. They always give you a graph for that, okay? That's a bit of a new concept there. Any questions about that? Yeah? So the solution is x equals to 4, y equals to 0, and 4, 0 is the point of intersection there. Can you guys write that down for me? Here's one for you to try. And this is where you're going to need your graphing skills. Ben, you got a question? Yeah. How does x equal to 4? Which one's the x-axis? Remind me. Well, as remember, there's an x and y-axis, right? So which one's x? Remember? The flat one, the horizontal one, right? So what's the x coordinate at this point? It's 4, right? So that's why x is equal to 4. What's the y coordinate at that point? Well, it doesn't go up anywhere, right? That's why it's y is equal to 0. Okay. Does that kind of make sense, how we get that coordinate? Yeah. Good question, Saxon. All right, so here's the graph of our line. I need you now to try and solve for this simultaneously. Remember, what's the process? Well, we need to actually have 2 lines. We already have one of them. They give it to you. That's y is equal to 6 minus 2x. What you need to do for me is, can you graph this guy? Y is equal to x plus 3 on the same set of axes. So this is where your linear functions come in, right? Can you graph that for me? And then try and find the point of intercept. What did I ask you to do? I asked you to graph this other equation here, y equals to x plus 3 on the same Cartesian plane. Caleb, can you help me out? How do I graph lines? What's your preferred method of graphing lines?
Using one program just looked back, to be honest.
Yep.
Saw that the 4 was the same line.
Okay, show me what you got. Have a look.
Just like
There it is. All right. All right, how do you feel about this guy?
4 years ago.
You got something different. How is yours different?
I did it through table of values. It's
Yep.
just that is much higher up.
Okay, so I guess one thing we can think of when we look at this one, one property we can think about is, what's the y-intercept of this line here? That's the first thing I usually look at. It should be 3, right? So the y-intercept, the first thing you want to be thinking about is, does it cross this point here? Okay, and so it doesn't. That's okay. You got the gradient right. It is positive, so that's one thing. Okay, but I guess some checks you can put in place are, is that y-intercept correct? Okay. Samra, you said you use a table of values. That's a good way to do it. Did anyone use another method by any chance? George?
I made y0 and
Yep.
just found the coordinate and found x and found y.
Yeah, so I guess everyone has different approaches here. Personally, once I've seen a lot of these kinds of equations, you start to recognize certain things. So I actually use the way that George does. And so what I'll do is I'll mark in the y-intercept, right, which is here. I know it's equal to 3. Sorry, there's a point missing there. The other thing you can do is then you can find the x-intercept. So how do you find that? Well, if you have y equals to x plus 3, for the x-intercept, you can let y equal to 0. And how do you solve an equation like this? Well, then you balance them out, right? What did you get, Tristan? Yeah. And so actually you only need 2 points to construct this line. Looks something like this. Yeah, your trusty ruler. There you go. That's the... I swear it's straight over here. I have no idea why it's like that on there. What does that look like to you guys? A little on the wonky side. What point does that look like, do you reckon? In an 1-4, yeah. Like, so in an exam, are you guys ready? In an exam, they would give you like a proper grid with all the right values and things like that, so you don't have to worry too much about that. But yeah, so 1-4 would be our point of intersection, which is nice. And again, you can check it as well by substituting it back into these equations, and they should work out in the same way that you had a simultaneous equation, right? But for this one over here, thank you. I don't get full marks. The 1 is from, so it's in between the 0 and the 2 here. But like I said in an exam, they'll probably give you more, yeah, they'll give you a grid, yeah. I don't know why that one doesn't have it. Sorry about that. Does that make